Hi everyone, my name is Marcus. I'm a Senior Research Fellow in Sports Engineering and Biomechanics, and I work in the Sports Engineering Research Group at Sheffield Hallam University. I've been asked to give a talk on why I studied sports engineering and why I pursue it as a career. So hopefully the rest of these slides will be useful in understanding why I've made these choices, and hopefully they might be of use to you as well. So I suppose how it started for me in sports engineering was with this device, the International Tennis Federation's shoe surface tester. And of course, Professor Steve Hake, OBE, who first offered me the opportunity to study a PhD with the ITF back in 2010. So I owe Steve a lot of thanks from that point of view in terms of how my career started in sports engineering. So I'll come back to this slide in particular a little bit later, but what I first wanted to do was give you a bit of a flavour as to how it's going. What do I actually do? So to be able to give you a bit of an understanding of how it's actually going, I thought I should probably give you a bit of an understanding of who I am and what it actually is that I do in my day job. Also some understanding of, how did I actually get there? What were my choices? What was my background? What was my career journey like? And also, hopefully, to make any use of this for you watching this, some points on advice that I think might be helpful for you. So first of all, it's really important to highlight the group that I work in. So the Sports Engineering Research Group has got a real history of supporting Olympic and Paralympic teams across the last 10 years or more, really supporting those teams in how they actually understand performance and improve performance in real-world sporting events. And of course, the group actually also have a number of well-established and strong research partnerships with international sports governing bodies, so the International Tennis Federation, FIFA, as well as international sports companies, so Adidas as well. So the group are incredibly proud of that history. And in early 2020, they moved across to Sheffield Hallam University's Advanced Wellbeing Research Centre. And this is a brand new state-of-the-art facility that houses some really impressive research facilities. Some of the QR codes that you can see throughout the presentation as well, you can follow those, and that will provide some more information about those. But importantly, the Advanced Wellbeing Research Centre really helped the group envisage new types of projects given the facilities that the centre offered. So coming back to who I am and what I do, if you were to read my biography, yes, it says what I do and what I've written and who I've worked with, but it's probably a little bit boring actually to read. So the next few slides, what I've put together is a few videos, visuals of the types of projects that I've been fortunate enough to work with and on over the last number of years, and hopefully they provide a bit more background into what I actually do rather than the text that's on the screen at the moment. So as I mentioned before, the group works with international sports governing bodies, and this is a project that I worked on a few years ago now. So working with FIFA, they had a particular question around new GPS tracking technologies that were coming onto the market, but they didn't yet understand what possible injury risks might be associated with those devices or wearing those devices. So they came to us to be able to understand what those might be and how we could create a test standard to be able to regulate those devices. So we went out to industry and spoke to different people, teams, medical doctors, as well as device manufacturers. And we identified that falling onto the device backward would represent the highest risk of injury. So we replicated that scenario, calculated the impact energies underneath the device that might get transferred through to the upper back where the player was wearing them. And we recreated a mechanical test, as you can see on the top left there, and then wrote that up as an international match standard. And that match standard has been used to be able to regulate all of the devices that come onto the market. And we can see a really I suppose, great example of Chinelli's foul on Saka in the Euros, where obviously pulls Saka back directly down onto the GPS device. And again, hopefully we feel that this match standard that we wrote might have had some bearing in making sure that that device was safe so that it didn't rupture and didn't cause him any injury other than falling on his back there. And it's not just that project that we've worked with FIFA on. So we've worked with FIFA for a number of years now. And on the top left, we've got an example of when we were able to assess the precision of video assistant referee lines projected into broadcast footage. On the bottom left, we've got an example of an assessment we did of different size and mass footballs on heading impacts in youth football. On the top right, we're now currently working with FIFA, trying to understand new metrics to characterize football performance to improve the standardization of footballs in match play. And of course, we go back to FIFA's home in Zurich and present those results at their research symposium and research synergies days. It's not just governing bodies that we work with to help them with regulatory aspects of sport. We also work with sports companies. So we've worked with Adidas over the years to look at football boot performance, so different stud configurations, custom-made boots to help fit individual players' needs. Again, this is another great example of an international company that I've worked with in terms of developing a new generation of tennis rackets. This is where we've worked with Babolat. We're trying to really understand exactly how tennis rackets are used during ground strokes to inform their future design. So it's not just sport that I work in. I also work in health applications as well, and particularly how to transition movement analysis technologies from laboratory to field or clinic settings. And this is a piece of work that continues to develop in terms of how we can transition advanced movement analysis technologies into devices that can be worn and used in a range of different settings. This particular project that was funded by Innovate UK required me to travel around the world, as we can see there on the map there, and speak to different users to identify different use case scenarios that this particular movement analysis technology might be used for. So I've also been fortunate enough to appear on TV a couple of times. So back in 2018, the top row there, I was fortunate enough to be asked to appear on the Royal Institution's Christmas lectures alongside Professor Alice Roberts and Professor Aoife McLeisite, who you can see there on the left with me. And this was really to essentially help understand, or viewers understand, how efficient humans are at running. And as we can see there, we've got our participant on the treadmill and also 3D motion capture happening in real time to be able to illustrate that stickman figure. And from what I understand, I think at the time that was the first time that 3D motion capture had been performed live on TV in an external setting. So we can see the cameras set up there in the library at the Royal Institution there. So that was a lovely piece to be a part of. And on the bottom as well, this was a BBC programme series about the truth about getting fit at home in 2021. So this is all about how we get fit coming back from the pandemic lockdowns. And this reflected a piece of technology that I was working on at the time with a client, and it was all about how we can capture videos of people running remotely with their mobile phones, as we can see in the middle there. Analysing those videos with a piece of software that I was writing to be used on a computer, and then sending that back out into the field so that Becky Lynn, who was the running coach in that particular piece, could able to provide meaningful feedback to the client. So I was also one of the directors of the International Sports Engineering Association between 2018 and 2021. And that was a really enjoyable role to perform. the RCA is full of people who are passionate about sports engineering from all across the world. On the top right there, this is our 2020 conference. This was so we ran this online mid-COVID. And again, it is great to see all the different people tuning into that event. So we made the event free for people to attend. And bottom right, we've got our annual conference in 2022 in Purdue, Indiana, United States. And again, as an academic working in sports engineering, I also contribute to the RCA's official output, the Sports Engineering Journal, which is a really important aspect of the community. And to build on that point about community and importantly communication, which is a really key aspect of being an academic, this was a great initiative that we set up between the RCA and FIFA, and this was all about improving or increasing the transparency behind the technologies that are now starting to be used, more increasingly used in football. So the Topple collection on football research is a collection that I led as a guest editor, and you can see and read all of those papers with that QR link just there. But again, really this was about improving the transparency about some of the technologies that are being used in football today. And I suppose last but not least, by any stretch of the imagination, I also teach. So I've recently developed 3 applied measurement science modules for an undergraduate course in sport and exercise technology. I lead the MSc Sport Engineering module, Applied Measurement in Sports Engineering. I supervise numerous PhD students, so 4 currently. 2 of those are out in Australia at the moment. I supervise 4 to completion. And also teach collaboratively with international partners. So the images on the bottom are some of our alumni and some of the courses that we've taught over in the Netherlands at the TU Delft. And the bottom right is kind of our most recent cohort of students that we've taken out there, which is an example of a really fabulous course. So to try to bring this all back to something that might be useful to you, and if you're trying to consider what your career path might be, in my experience, careers are not easily defined. So for example, the work that I'm doing now might represent a small segment of my career. Okay, and most jobs or segments of my career path, certainly to me, might not have existed or not known to me at different aspects of my career. So a lot of the work that I do now, I didn't know existed when I was studying for A-levels, my undergraduate degree and so on. So I think that's really a really important thing to bear in mind. So to try to illustrate this, I've pinched this graphic off the internet from somewhere. And again, we can sort of see, this last green line here. This might be my current job. This vertical line is today. The x-axis here is knowledge, not time, but knowledge. We can see here as you progress through your career, you make different choices and you follow different paths. It's important to note that actually as you go forwards, you can only have more choices that come to you. So what does this mean? So we can potentially look at this. So my first choice might have been around when I was at school. I've obviously then made another set of choices when I went to college to study A-levels. I did a gap year, and whilst some people might not think that as being part of a career, I think that it frames what your thinking is, your aspirations, what you might want to do. So it's an important point in your career journey. Obviously then I did an undergraduate degree. I made choices there. I went on to do a postgraduate degree, so a master's degree. I then started a job, so I decided not to continue education there, but actually to get a job for a period of time. So I worked as a technician. I then went back to university and studied for a PhD. I then did postdoc positions, 3 of them, and then finally ended up at the position where I am today, where I have tenure or a full-time permanent post in academia. But it's also important to note that I'll have future choices to make in my career path as well. And again, this might take me in different directions as my career progresses. So I bet you're all dying to know what I did at school. Well, here we go. So I did 10 GCSEs, Science, Maths, English, DT, German, Sports Studies, Economics. I won't go through my grades. They were average. They weren't amazing. But I suppose that the key one there in terms of sport was Sports Studies. At the time, I don't really remember what drew me to Sports Studies. It was it was an intentional choice. But I think at the time I had an interest in human physiology and in kinesiology as well, in particular the application to sport. I put on my part-time work just to kind of help highlight how this might change in a few slides. But I worked with in a pet and reptile shop. Nothing really linked to sports there, and I think that's fine. We don't really need to be too concerned about focusing absolutely everything to what we might want to be doing in a career at a very early stage. So I chose to stay on at college, or my sixth form college, and this is really because I had an aspiration to attend university to further my understanding in human physiology and kinesiology and sport. I studied 3 A levels in physical education, sociology, economics. Again, I'm not going to go through my grades. They were probably a bit below average at this point in my life. But I think the key thing is there's, again, probably not your traditional choices if you were thinking about moving into sports sciences, sports engineering. Usually you might expect some maths and physics in there. I think I had quite a broad range of topic choices. I think at the time I was just pursuing subjects that I was interested in and things that motivated me to study, which again I think is a really important point. I've also highlighted on my part-time work, so I started work as a lifeguard and a gym instructor at the local sports centre. So I think this started to reflect my interest in sport and kinesiology, human physiology, and so on. And I also started work in computer sales or computer game sales in Electronics Boutique, or I think it's now called Game, or it might have been changed since. But this starts possibly to highlight a bit of a flavour of my interests in and around sports science and engineering that I do now. So I did a gap year. So I travelled to Australia and New Zealand for 6 months by myself. The reason why was because I wanted at that time a break in study. I needed a change in status quo in my life at that time. But I think the really important things that came from that was that I developed independence, resilience, and a love for travel as well, which again, if I look at what I do in my career now, actually features in a lot of the work that I do. So again, I think actually it's a really important step in my career journey. So I went to the University of Portsmouth for my undergraduate degree. I studied Bachelor of Science in Sports Science. I gained a first-class degree. I also was awarded the John Wiley and Sons Prize for the best final year project. Why did I go there? And I think this is really important. I like the atmosphere. The course met my needs in terms of what a sports science course was. It was my first introduction to sports biomechanics, which is again a really important point. But I think at an undergraduate level, I think that's all you need to worry about. If you're considering what your choices for university are, I think those things on atmosphere, whether the course meets your needs, again, whether you feel comfortable there is probably the most important thing to consider. So really, coming out of my undergraduate degree, I obviously refined my interest in sports biomechanics at that stage, and obviously made lifelong friends, and this is a really important aspect of going to university. So I then opted to study a Masters in Sports and Exercise Science at Sheffield Hallam University. The reason I did this was really simple. I wanted to continue developing my skill and understanding of sports biomechanics, and Sheffield Hallam had some world-renowned expertise at the time. I think Professor Roger Bartlett, who was an eminent biomechanist. I think he retired shortly before I arrived at Sheffield Hallam, which was a little bit of a frustration. But of course now Professor John Wheat, who's the Associate Dean for Research and Innovation at Sheffield Hallam, was my then tutor, and obviously now colleague as well. So some really great expertise there, which is why I moved there. And again, what did I do? I developed research and biomechanics expertise, and in particular three-dimensional motion capture. So on the bottom there you can see a video of that's a badminton drop shot. My master's project was around understanding kinematic chain differences between the smash and the drop shot to understand how a player might fake a smash shot and play a drop shot and set their opponent off guard. I also then moved into some part-time work, voluntary part-time work. I think when you're at university, you won't make any beans about it. This it is a competitive marketplace. You need to be able to differentiate yourself. So I was taking on voluntary roles at Sheffield Wednesday Youth Academy and doing strength and conditioning, which built on my experience as a gym instructor. And again, I think this is a really important thing to highlight. And again, it highlights my transition to more specialised work patterns. So after I finished my master's degree, I took on a biomechanics research technician post at Sheffield Hallam University. Why? It was a job, for one, but importantly it aligned to my expertise that I'd started to develop through school, college, undergraduate and postgraduate study as well. So this really helped me to, again, develop more expertise, certainly in research and teaching settings, but also it aligned to everything that I was doing, and I was developing more skills as I was going along in this post. So after about 4 years, I think, working as a technician, I decided to quit. I wanted to study a PhD to develop myself. I'd met Steve a number of times at this point, and Steve offered me a choice of one of two PhD projects, and the one I chose was the one that was funded by the International Tennis Federation, and this was really an amazing opportunity to experience self-directed study and research, as well as working with an international sports governing body. Obviously at the front of this presentation there was obviously this image of the shoe surface tester and Steve himself, and this is where it started, and this I think is a really important point to reflect on. A lot of my work starts with how do we represent reality. A lot of my work now is applying measurement technologies in real world and representative settings, and that probably stems from this problem where we had this contraption on the left hand side which was supposed to replicate a shoe surface interaction, but as we started to find out, it didn't. And what we needed to do was take a few steps back to understand, well, what is the program of work that we need to be able to do to inform this type of device. And what that led us back to was what my PhD actually became, which was a process of video processing algorithms, which were developed into an analysis tool which allowed us to track tennis players moving around a tennis court without any markers, without any sensors, processing images of those tennis players to identify when their feet contacted the ground. From there, you can use camera calibration algorithms to determine the step lengths and step frequencies of those particular movements. And from the ITF's point of view, we can then start to profile the step lengths. So on the right-hand side, we've got a histogram of step lengths used in match play tennis. We can see there's a heat map there, so we can see where the largest ones are occurring. So that's might be indicative of a potential risk for slipping and so on in tennis. And this was really important. This was new knowledge that hadn't been captured before, and it provided insight into tennis, but importantly, it informed those next stages of that research program around developing mechanical devices that might hope to replicate human movement on a tennis court. And also, again, I always get pulled up on this, so I put these in presentations now, that very last data point on that histogram is quite a large step length. It is real, and those are the actual images that were used to inform that As we can see there, so it's quite a jumping lunge. That's about 2.5 meters, I think, something like that. So after I finished my PhD, I took on a fixed-term contract with the group simply because I wanted to continue learning and to develop new skills with the world-renowned research group. So you can see I had 3 fixed-term contracts before securing a permanent post. A lot of the work that I was doing was industry-led contract research, so we would speak to industry partners, identify their problems, and propose and develop often quite complex measurement solutions for them. These were often also delivered internationally and often within tight timescales. So problem solving was a real key skill to develop as well as resilience. And importantly, to be able to critique your own concepts and what might happen in the event of failure, because it happens a lot. But again, it's important to be able to critique and understand why things go wrong, so that you can progress and develop things better in the future. So the next slide is just a video of my first postdoc position, or the outcome, which was a performance analysis tool developed for athletics based on my PhD work. So I'll just let that one play through.
So the gait analyzer system is a video-based system. Essentially, it's got a camera that films the last 10 meters of the 100-meter straight. And what it does, it analyzes those images that comes from that camera, and it automatically identifies where an athlete's feet contact the ground. You can do that without any markers or without any sensors, so the athlete can do their training totally without being interfered with from a technology point of view.
So hopefully that last slide just gives a bit of a flavour of the type of work that was developed, again, from my PhD work into a real-world performance analysis tool. That tool would give the athletes feedback within about 3 seconds, so it was a really actionable, usable performance analysis tool for athletes training in sprinting, hurdling, and so on. So some of the other projects that I worked on in my postdoc positions, again, here got some examples of bespoke measurement solutions. So on the left, we've got volleyball line calling systems, automated line calling systems, and we had to measure the precision of those systems, and that's Copacabana Beach over in Brazil. In the middle, we've also got goal line technology testing here, where we're assessing the precision and the speed of automated goal line technology systems. And again, I did this all around the world, so we're talking Brazil, Japan, across Europe, in Kuwait, all stadiums, a lot of different stadiums across the world. On the right-hand side, we've got a really unique setup where we're actually measuring jump distances for the jump program that was broadcast on Channel 4. You can see there we were using a high-speed camera to measure the distances that the celebrities were jumping. So I continued to develop my expertise in computing so that I could work on projects like this. On the top left, we've got an example of automatically tracking and extracting step rate and step count information from our 100-meter sprint athletes. On the top right, we've got an example of a project we did with New Balance, where we're doing the same but over the New York Fifth Avenue mile race. So we automatically counted all of the steps and the step rate of the lead runner Jenny Simpson there, using only broadcast footage. I've also used pose estimation, so the identification of joints, to be able to inform software for run coaching, as we saw with the previous example that was on the BBC programme. I've also developed softwares using depth cameras to take 3D scans so that we can provide feedback of posture with physiotherapists. And most recently, on the bottom right, I've got an example again of using pose estimation to be able to do functional movement screens using an iPhone, again with a client locally in Sheffield. So I just wanted to reflect really quickly on this graphic again. because I think it's really important to think about how complex career journeys actually are. You might well be able to reflect on some of the decisions you've already made, but importantly, know that there will be decisions that you can make in the future that will open up new opportunities to you in the future as well. And again, that will all be dependent on the knowledge and skill sets that you have, putting you in different positions to be able to make different choices. So to try and summarize and hopefully give you some sort of advice that might be helpful, I think it's really important to reflect that careers often make most sense in retrospect. You can look back and start to say, okay, this decision was made because of this, and I was interested in it. That's all well and good, but it can be then difficult to plan going forwards. So what do you do in terms of building a career? I suppose my advice is around, first of all, finding out what you're really passionate about. For me, studying sport, human movement became really clear quite early on for me. Beyond that, challenge yourself, look to develop new skill sets. It's important to recognize that the opportunities come about because you have unique skill sets and because you're the person to go to be able to offer insight and expertise in a particular area. Take opportunities, meet new people. If something comes up, a new opportunity comes up, take it. It will potentially lead to something else and provide you with different choices that you can then make in the future. And also travel and stay active. Usually if I'm traveling with work, I'll always throw in a pair of running shoes so I can go for a run. At the very least, it will help combat jet lag. But again, for me, keeping active in terms of going running is a great way of keeping on top of stress and all the other factors that we have to deal with in the modern workplace. So very lastly, if you're still watching, thank you for watching. I hope it's been insightful for you to understand why I've studied and pursued a career in sports engineering. Hopefully also some of the advice might be useful for you in helping to plan and develop your own career journeys as well. Very lastly, there's a URL there, a link tree, a link, a QR code goes to the same place if you want to find out more or get in touch and so on. Thanks very much.